Okay, so let's get started. Hi, everyone. My name is Ophir from Rivery. Welcome to the webinar. Before I get started, I wanted to go over a few quick housekeeping items. First of all, this webinar will be recorded and you will receive an email tomorrow with a link to the recording so you can watch, take notes, and share with your colleagues. Also, please note all attendees are muted. So if you have any questions during the webinar, please ask them in the Q&A box, which can be found on your Zoom control panel. And we'll do our best to get to those questions during the Q&A session at the end of today's session. So let's go ahead and get started. My name is Ophir Prusak. I am from the product marketing team at Rivery. And we also have with us JJ. JJ, do you want to go ahead and introduce yourself?
Hey, how's it going, guys? I'm JJ. I'm a solutions engineer here at Rivery, working with clients on technical implementations. I'll be leading the tech demo today. Thank you all for joining.
Awesome. So with that, let's go ahead and get started quickly regarding the agenda. So I know a few people today are not familiar with Rivery. So just in a couple of minutes, we're going to go a little about Rivery. Then we'll get into why it was so important to us to add Python and what we're doing with our Python integration. We'll discuss how Python actually works in your data flows, a little before and after the integration, a quick overview of the user interface, and then we'll show some live demos. JJ is going to be showing two live demos, one of a simple example and one of a really cool machine learning example. Then we'll talk a little about debugging and version control using Python, Rivery Kits, some of the cool features we have coming soon, and at the end, some Q&A. Before we get started, just a really quick Python usage poll. I'm curious to know, for those of you today in the audience, are you currently using Python in your data pipelines or workflows? I'll wait just 30 seconds for everybody to answer, just to get a better idea of, what the audience is like. I know like a lot of people are using Python, but curious to know in today's audience, is this something that you're currently doing, thinking of doing soon, or not using at all? So we'll wait just maybe another 3 or 4 more seconds. And at that, I think we can go ahead and close the poll. Should be good to go.
Looks like we have 63% who are currently using Python in their
Awesome.
pipelines or workflows, 20% not currently, but plan to soon, and then another 18% not currently using Python.
Okay. Thanks so much, Alex. Okay. So it looks like the majority of you are already using Python. So you're really in for a great treat. And those of you who aren't, you're going to see how easy it is to use Python using Rivery. So let's continue. And again, just a really quick 1-minute overview about Rivery. So we like to call ourselves a full stack data management platform. Rivery has over 180 fully managed data sources out of the box. And we also support all of the major data warehouses as targets. But what really sets us apart is that's just a small subset of what you can do with Rivery. We have built-in orchestration capabilities, which rival many standalone tools. We also support agile development and deployment practices. For instance, we give you full version control of your pipelines and your workflows. We also have multiple environments for dev and staging. So we support kind of built-in deployment scripts for your deployment process and really allow you to do development like you would of a product. We also have something called starter kits, which are for most common real-world use cases for building workflows. It's a pre-built one-click install that takes care of the entire data flow and data pipeline and workflows, including all the transformations, the schemas, the SQL scripts, and in the future, also Python scripts to basically give you kind of that one-click install of from click to insights and moments. For example, pulling data from TikTok, let's say Facebook, Twitter, and Snapchat, joining all that data together and pushing into your data warehouse. And we even support reverse ETL for those of you who are looking to push data from your data warehouse into your operational systems. We actually started as an internal tool at one of the world's largest BI consulting firms, and we were looking for a data stack that we really liked, but we couldn't find anything. So we simply decided to build it ourselves. We have offices all over the world, New York, Tel Aviv, et cetera, as well as companies from all over the world, ranging from large Fortune 500 companies to small startups. But I think our customers really describe us the best. I would say almost every customer that I've spoken to has said that Rivery does the work of at least one full-time data engineer. And this is a direct quote of somebody saying that they were looking to hire some more developers, and basically with Rivery, they could do it all on their own. But enough about talking about Rivery. Let's talk about Python while we're all here. So why did we decide to add, why was it so important to us to add Python to Rivery's capabilities? What we've seen is that within the realm of building pipelines and workflows, you have on one point, you have the kind of the no code solutions, which are very easy to use, but the capabilities aren't quite as complex and powerful as the programming language based solutions. These are solutions which you need to be a software developer. You need to be a data engineer, very powerful and customizable, but they're very hard to use. And Rivery could really handle most of the use cases before we added Python, but not all of them. For instance, if you want to do machine learning or complex data analysis, sometimes there's some optimizations you can do for custom performance or custom connectivity. That's where you need a programming language like Python. And now that we've added the Python integration, we really give the best of both worlds. You have, for most use cases, an easy to use solution, which can do most of what you need to do. And for those edge cases or really powerful customizable cases, you have Python. So now let's go into actually what it looks like to be using Python with Rivery. So before the integration, what we saw was a lot of our customers were going through multiple steps to get the data where they wanted to basically be able to use in Python. This involves both security and maintenance and kind of how do we get the data where it wants to go in terms of spinning up some resources. Basically, there's a lot of steps involved when you have two different systems. But now with integration, it couldn't be easier. You pull the data directly into your data frame. You execute your Python script using the data you just pulled into your pandas data frame. And then you simply push the data from the data frame into whatever data warehouse you want. What does that look like in reality? So in reality, what you're going to be doing is in the first step, you're going to be pulling data from a data warehouse as a source to a data frame as a target. Then you're going to execute the Python script using the data frame directly. And then last but not least, save the data from the data frame as a source and push it into a data warehouse as a target. Let's take a look at what that looks like in the actual user interface. So there is a new step in when creating logic rivers. A new step. There's a new option when creating logic rivers. When you are doing a SQL/DB transformation step, then what you can do is under target, you now have a new option called data frame. So basically you're pulling the data from your data warehouse and pushing it into a data frame. We then have a new type of logic step called Python, which allows you to execute the Python itself, which JJ is going to show you. And then when we want to get the data out of the data frame into your data warehouse, we now have a new type of source called data frame. So enough of me just talking about Python. I'm going to go ahead and pass it over to JJ, who's going to show you what it actually looks like in reality.
Thanks, Sophia, for that introduction. I'm going to share my screen now to go through what building a river using Python integration actually looks like. So the first step here, if you're familiar with Rivery, is to build a logic river. The logic river is our data transformation engine and is really sort of what sets Rivery apart from other data integration workflow tools. So when you hit create logic river, you'll see right off the bat that there's a new feature in the UI called data frames. Here, we actually leverage a pandas data frame object. If you guys are from the world of data science, data engineering, it's probably one of the most robust interfaces for moving data into and out of a data structure. So here, you can add a new data frame, click new data frame, and we're going to call this hello world. Pretty soon, we're going to add the ability to preview data frames directly within Rivery. For now, you can just create them and you can preview them from within the console. Now, the type of step that we want to set up for data frames in order to move data into them is actually a SQL/DB transformation step. So this step here, we're going to choose our data warehouse, which is going to be Snowflake, set our connection. And we see here that we have the ability to put a SQL query. We can also pull from another data frame that I'm going to show you in a little bit. And for our target, we now have a new feature called data frame. So here, we're going to write our query to move the data that we want into our data frame that we just created. So the first query, very simple, just a simple select. And just real quickly, I'm going to show you what this looks like in Snowflake. So just a simple data structure, 4 rows, and just basically a little bit of text. Here, we're going to select the data frame that we want to move into that we just created. And it's as simple as that. Now we have data from our data warehouse, and now we move that data into a data frame. So the magic really happens when we add the Python step. For here, we now have a new step type. Where before we had river, actions, snowpark, DB transformations. Now we have Python. Here we have the ability to either import a Python file, write our Python code inline, which is what we're going to do for this demo, and set our resource size. So this is something new in terms of the amount of computation needed for this specific Python script. We have preset EC2 clusters that are optimized to handle the computational load. For this case, it's going to be a simple hello world, so extra small is fine for us for now. We also have the option to download this Python script. If you guys are using any version control VCS, you want a way to archive this script, this is a handy way to get this information onto your desktop. And we also have the ability to add custom packages. So if our current Python implementation comes with these popular packages already that are used for data science, data engineering, visualization. But if you want to say add a new package, say you want to have some custom package designed to say move data in bulk, you can add that package here. So something maybe like Salesforce bulk. If it can be installed via pip install on your desktop, you should be able to import it into your virtual environment by adding that package here. You can also add different versions of packages. So the versioning that we have currently is set here, and the syntax for adding a specific version just equals with the actual version name of that package. So if you have like a requirements.txt file for your Python script, you can simply copy paste over those requirements and have them imported into your virtual environment here. To actually work with the data within Python, we have some Rivery specific syntax in order to bring that data frame into the virtual environment. And I'm going to show you that. Open up this text file, and we're going to do a from Rivery underscore data frames import, and we're going to choose the data frame that we created earlier. Hello world data frame. So now this first step will bring that data frame into the environment where we can now do some work with it, perform computations, pretty much any function that you can apply to a pandas data frame, slicing, indexing, transforming, joining, appending, you can do within Rivery. First thing we want to do is we're going to print out the contents of this data frame. This is easy. Just run a print statement. And choose the data frame within these curly braces. The next step we're going to do after we print out is to print out the data frame size, and we're going to append a record to this data frame. So I've written out this code here, just going to copy paste. So here we're going to print out the length of this data frame, and then we're going to add an additional record. The Rivery specific syntax that allows you to actually append to the data frame within your environment is a simple .append function. What this will do is allow you to take your modification that you made within your local script and have that transported to the actual Rivery environment. And you're going to need this if you eventually want to load the contents of this data frame into your data warehouse. So we're going to type that out now. A handy little autocomplete. .append. Simple as that. The last step is we're going to print out the contents of this transformed or appended, modified, call it, data frame, and have that be posted to our logs. And I'll show you what that looks like. So we're done. Our Python script now ingests the data frame that we extracted from Snowflake earlier, prints out the contents, appends an additional record, and prints out the final data frame. The next step we're going to do is we're going to take the contents of our appended data frame and push it to our data warehouse. And the way that we're going to do this is by adding an additional step and have it set to SQL DB transformation. Set our connection, set our connection name. And here in our source, as I showed you before, we have a new option called data frame. So we select that, and now we select the data frame from before, which has now been modified by the Python script. We take this data frame, and now we want to load it into our table. So we're going to choose target and have this set to table. And now we're going to type in our database schema and table name that we want to create with this new data frame. And we're going to call this hello 2. We're going to set our loading mode to overwrite for now. And we're done. And let's give this river a name. And save. Cool. After all of this setup, we simply go to execute our river. And I've actually already executed this, so I can show you guys what that looks like here. So all of these steps have executed, and now our data frame has been created. We can now go into the logs to see if our data frame implementation was successful and our modification was made, and then we can confirm these changes within Snowflake. So here we can see that our data frame, what it looked like before. After we added that additional record, we now have a 5th record that has shown up here. And for the final step, I want to show you what this looks like within Snowflake to show you that that modification has gone through successfully. Now here we see all 5 records have been pushed to Snowflake. Our modification has been made through Python, and now this data frame has been ready. So that is the simple implementation. I would want to give a few minutes for any questions on the UI side before I get into the use case, which is a machine learning one.
Thanks, JJ. So we actually do have a few questions already that I'm going to go ahead and answer. This is really interesting, by the way. So the first question is it possible to create a reusable environment, or do additional packages need to be imported for each implementation? So the short answer is it's on our roadmap. We really wanted to get Python out there so people can start playing around with it. We're well aware that there's some features and functionality which everybody's going to want, but we really want to get it out there quickly as possible. So at the moment, it's not a live feature, but it definitely is something on our roadmap. The second question is, would it be possible to point to a repository.py file on GitHub and use it as a requirements file for the packages? So I want to say if it's a private repository, the answer is not at the moment. We need to look into adding that as a feature. If it's a public one, it should work. It's definitely something which we could do, I want to say, as part of the actual setup itself, if it's a public one. And again, we can go into details more later. Again, a question about the recording. Yes, this will be recorded. This entire presentation is being recorded, and everybody will get an email with a link to the recording. And also there's questions, can I use Python to export the data in CSV format? So the short answer is, at the moment, if you want to push it, you could push it into Python to somewhere you wanted, but ultimately the way we have it set up at the moment is specifically to pull and push to a data warehouse. We are working though on other targets. So in the future, it is something on our roadmap where we'll be able to push the data, not just to a data warehouse. Also, the question of what version of Python is being used. I'm not quite sure of that. I do know, by the way, we do having a roadmap to support multiple versions, but at the moment it's just one version. Does anybody know offhand what version it is? I'm looking here. It's
Yeah,
3.8.4. Here we go. So 3.8.4 is the version which we currently support. And in the future, I know we plan on supporting other versions as well. Somebody asked, is it possible to use Python for API requests? The answer is definitely yes. Part of the reason we are doing this is because some people have edge case of they want to be able to pull from a specific data source, and we don't have it out of the box. We don't have it with what we call action rivers, which can actually support some type of API requests. So yes, you can definitely use it for API requests, in which case you wouldn't necessarily have to have the initial step, which is pull from, a data warehouse to a data frame. You could just start with Python and just go ahead and pull data to an API request and then push it to your data warehouse. And I think that's it for the questions for now. So if that's it, JJ, I will go ahead and let you continue with your really cool machine learning example.
Thanks, Ophir. And great questions, guys. This is exactly the point of the webinar. We want to make sure all of our clients are enabled for when this comes out. Cool. So now I'm going to go through what an actual use case would look like within Python, within Rivery utilizing Python. So one popular use case is binary classification on data that is archived or stored as a basis for training a machine learning model that will help make those additional classification. A popular use case is predicting customer churn. And this is important because say you have a repository of customer data and you want to see which customers are at a high level in danger of possibly churning, and make sure that you can focus your business efforts on making sure that those customers don't churn. So in this case, what we do is we perform a full end-to-end data ingestion to prediction. And the first step is utilizing our sort of data source to target functionality to actually ingest two data sets. The first one being our your entire customer data list. And I'll show you just real quickly in Snowflake what that would look like. Give me a second here.
Hey, JJ, while you're waiting, just a quick note, I'm getting a lot of more Q&A, and just to let everybody know, we're going to have another Q&A session at the end of this demo to go over all the rest of the stuff. So if you asked a question, we definitely will answer it at the end of this other example.
So here we see we have 7,000 rows of data that tells us a customer ID, certain features of those particular customer IDs, and we finally have a classification. So this is the data that we're going to use to actually train our models. And then finally, we're going to pass in a data set that contains new customers, a set of 10 new customers that we want to see if they would be likely to churn based on what the training data is telling us and how the model what the model has predicted. So the first step after the data ingestion is to construct our data frames. So here we take the results of our query to get our customer test data and put it into a data frame. Second step, we take our list of 10 new customers that we want to predict on and create another data frame. The next step is to build our Python code. So here we see we import in many libraries that we're using to both pre-process the data, build our models, and make our classifications. We also have that statement, the Rivery specific syntax to bring in the three data sets, the test data, the data that we want to predict on, and then the output data frame that's going to hold the predictions and the customer IDs for the customers that we want to predict on. We've defined some helper functions here to help us both encode the data. As you know, with machine learning, data needs to be encoded into a numerical format for it to be passed into the algorithm, and our actual algorithm. So we build a linear regression, logistic regression, and a decision tree. And we then print out the scores for how good they were at predicting the outcome. And then we pick the best model to actually do our prediction. Lastly, we take our prediction and we push it to a new data frame, the output data frame, and that we're going to eventually push to our data warehouse and append it to our prediction data to help determine which customers are likely to churn. So those subsequent steps here, we take our output data frame from the Python, push it to a table, and then we join that table onto our prediction table to actually get the insights that we want regarding which customers are likely to unsubscribe. But essentially, I want to show you the input and the output in Snowflake and just show you guys that after the execution, we're able to get our insights and append them to our table. So here we see the data for the 10 customers that we want to predict. We don't obviously have a label assigned to them because that is the point of the script. So after the script is run, we have a table prediction data output final. And this one has the churn predictions that we printed from the Python script. And now those have been pushed into the data. So now we can take this data and now focus, okay, customer ID 845-8456 QDAVC is at danger of churn. Let's send them an email. Let's see what's going on and see what we can do to help. So in this way, you can see the real business value of this, and that you can use this Python script to deliver more sophisticated insights than you could do without Python, as was before. Next, I want to talk briefly about version control and environments. In order for best practices regarding Python, we have an ability using our CLI to extract the entire configuration of this file and push it to a YAML configuration file. And this would include the text for the Python script, any SQL queries that were used, and then you can take this and sync it up with a GitHub repo. We actually have a whole community article dedicated to this whole flow. So for those of you that want to have a more robust system than the sort of version control that we have built into our rivers, there is an option for that. In terms of logging, which is another sort of popular data ops best practice, any print statements that are executed within the code here, those will be printed to the logs, which right now I'll have to bring up in another browser. But those logs will have all of the data within your script and printed out at the point at which they were called. So for logging, put as many print statements in your code as you want, and you'll be able to see how the script executed at that particular point. Further, going on to the data ops best practices, Rivery environments support deployments across environments with Python scripts. So any rivers that you build in, say, a dev environment, you can migrate over to production or staging and have that transition be seamless. And you can do that directly within the UI using our environments tab. Next, I want to hand it back to Ophir to talk about where we see this Python capability going into the near future. Thank you guys for tuning in for the tech demo.
Thanks a lot, JJ. So, and again, we'll get to the QA in just 1 second, but I do want to talk a little about what's coming up soon. So a lot of people have been actually asking, when will this finally be released? Python will be released on March 1st, which is in exactly 1 week. If you have any additional questions before that, you can always contact us. But this will be released to the public on March 1st. So definitely watch your inbox. In terms of what's going to be launched on March 1st, so at launch, we are only able to support Redshift and Snowflake as a data frame source or target. You can obviously run your Python scripts as you want, but the whole functionality that we showed you with pulling data into or out of a data frame from your data warehouse, that's only going to be Redshift and Snowflake. Other data warehouses are coming soon. As JJ had mentioned, we will also be able to preview your data frame in the Rivery UI, so you can actually see what data is without having to go through any other systems. Improve spin up time. So even though we didn't show you here, obviously there is going to be, when you run a Python script, some overhead just to spin up the actual instance. Currently, it's around a minute plus, and we're working on making that even faster. And then last but not least, Python kits. So for those of you who are not familiar, Rivery has this concept of kits, which are literally one-click installs, which will take care of the entire workflow in terms of doing certain things, like I said, pulling data from multiple sources. The Python kits will be able to support like the examples that JJ has shown. So basically one-click installs of already having the Python script installed for you. So at that point, I do want to open it up to the Q&A. And by the way, if you have any more questions which are not answered in the QA, you can either send an email to contact@rivery.io or just go to our website at rivery.io. And you should be able to get a lot of answers there. So at this point, I do want to open it up to Q&A. We have a lot of questions, and hopefully we'll have time to go through all of them. So the first question is it possible to edit the Python script in an editor that is not ours? Yeah, yes, you can. There's obviously you could copy paste, but the other way is there is a button, and actually maybe I'm going to stop sharing a second. JJ, can you bring up the UI? Because I want to show that there's a button in the interface for Python step right there, that little button, import file, which allows you to just go ahead and import a file into it. So that's one way definitely of doing it. The next question is there a list of libraries which are currently supported? So again, can you click on the packages tab there? Okay, so the packages tab, these are the ones that we have out of the box, which means they're always going to be there. You don't have to import them. So that is the list of libraries that are currently supported. Over time, we definitely will be improving this. And if you are a customer in the updates, we'll let you know when we add more libraries, which are the ones out of the box. There's another question. How can we use multiple Python scripts together? For example, implementing object-oriented programming or functions and the main script to execute them. You know what? I want to say that's a bit beyond the scope of the short answer is not at the moment, but it's definitely sounds like a feature we should look into. And again, there's a lot of stuff which we're going to be creating for this, but definitely it's interesting to hear about how people want to use this. At the moment, the answer is no, but definitely something which we could look into. And then there's a question, will this be able to execute operating system tasks such as reading native files? So regarding reading native files, you know what? The short answer is I'm not quite sure, but if maybe JJ, or we also have, by the way, with us today, Gilad and Israel, who are the two developers who actually built this awesome functionality. I'm not quite sure what the answer is there.
Yeah, the answer is yes.
There you go. So
operating system files. Yeah.
So the answer is yes.
Possible.
Okay,
Yeah.
definitely possible. Again, just a reminder, these are running on EC2 instances. So whatever you can do in Python on an EC2 instance, you'll be able to do here. There's a question, can you explain a bit more about memory and CPU selection while using Python? So this goes back to how basically what the resources are of the machine that you're doing. If you're doing just a simple, let's say, reading from an API, then you probably don't need too much kind of horsepower. We are spinning up EC2 instances in order to execute your Python. If you're doing a large machine learning process and you're reading in, a lot of data, you're going to need a more powerful machine. So the question is, how big of a machine would you need to run kind of an EC2 instance to execute your Python? That's ultimately the question of how big a resource you need to do here.
I can also jump in here real fast to talk about that. If you guys are familiar with a Big O, that would be a handy little benchmark to go with. So depending on, say, the type of computations you're doing, you're taking like a 1 million row data frame and like computing some information to create another row, maybe like an average or a square root or some other process. You should be able to just approximate. And I know there's some IDE tools that let you calculate how much RAM and CPU would be required to handle that. And then you would just match what you're getting in your IDE or a development tool with the resource size that's available here.
Got it. Perfect. So thanks a lot, JJ. There's a question regarding timeframes for other data warehouses, specifically BigQuery. And I am told that the timeframe for BigQuery should be next month. So I mean, by next month, it'd be sometime kind of around a month after we launch. So it looks like it shouldn't be too long. There is a question also, do we support Spark / Py.SQL? And also, do we support Kafka and some other streaming libraries? Not quite sure what to say there. If somebody else wants to jump in regarding, do we support Spark and Py.SQL?
Everyone. No, we currently do not support it, but we will be in the future. We yet to be sure which one exactly. So we will keep you posted.
Perfect. Thanks a lot. And the question is the code generated, or okay, so I'm not quite sure what this means. Is the code generated or does the user put it on Rivery? The idea is that you upload your Python script. You either type it in the box or you upload it, but the Python script is being executed in the cloud for you. And the magic of Rivery is that getting the data into or out of the Python script is really easy because you can just use Rivery's data frame option to literally pull it into or out of a data warehouse. Can we import variables into the script? So actually, we forgot to even show you. Yes, the short answer is yes. For those of you, again, who are not familiar with Rivery, we do have the concept of environment variables in Rivery. And as you can see here, in terms of the target, you can literally say that the target is a variable, and you can use an environment variable or a River variable, and then you can still pull those variables into your Python script. So we just show you how to pull a data frame, but you can actually, as JJ is showing you, from Rivery _variables, you can port and then the name of the Rivery variable. So yes, you can easily import variables into your Python script as well. That's an excellent question. And then what's the difference between Rivery and AWS Glue? Okay, that's an awesome question. I want to say this for those of you, again, who are not Rivery customers. We can support, I want to say, what almost any other ELT/ETL tool can there, but 10 times more as well. So I will say for a fact, I know a lot of our customers were considering AWS Glue and decided to go with us. But you know what? Go to our website and just ask for a demo, and we can go into those as well in terms of kind of your needs. Somebody asked, this is an interesting question. Can we use a parameter in Python? So I think it was answered, but if I understand correctly, in other words, when you launch Python, could you send in parameter to it being launched? Is that the question? I'm not quite sure if that was the question. But you can use variables. So you know what, even if you couldn't do that, you could use variables, which are definitely a way. I don't think you could pass in any parameters to the execution of Python, but you can definitely use variables. And I'm looking through more questions. There's a question regarding pricing. Okay, so again, regarding pricing, pricing is dependent on 3 factors. There is the factor, actually, I can show you a slide here, but pricing is dependent on 3 factors. Just one second, and I can even show you here. Here we go. So 3 factors. One is server size. One is how long it's being executed, and the last is network bandwidth. So basically, the smaller the server, the less you're being charged per minute, per hour, and the larger the server, the more per hour. These are the prices, again, for RPUs, and RPUs really depending on what package you have as a Rivery customer. Going on to the other ones, can the use of Flask be considered? I'm not sure what to answer there. I'm not really a Flask user. Is there somebody else who can maybe answer that? Can we use Flask?
There are a few similar things that we will be considering using in the future. It's definitely on our roadmap, same with Kafka that you already mentioned. So we just wait and see, but it's definitely there.
Sounds good.
If I started talking, I just want to answer another questions about someone asked about OOP. How can we use multiple Python script together? For example, implementing OOP or functions and main script to execute them. So currently we only support one model file. We definitely understand the need for multiple files, and it might be considered to be implemented in the future. For now, we can just take all the classes to one file and execute it in a single module. If anyone has any questions about it, just let us know.
Thanks a lot, Gilad. And then there's, again, a question which we kind of covered, but we'll go over a little more about testing the code locally without deploying it to Rivery. So, I mean, obviously, in terms of best practices, you're going to want to run it locally on your own machine. But in terms of how to test it overall, again, you're going to want to make sure that it can run locally on your own machine. And then when it works locally, upload it and add some print statements, because obviously when it runs in the cloud, it's going to have slightly different permissions. One thing to make sure, just in terms of if you are connecting to resources, make sure you have whatever IPs need to be whitelisted for those resources, stuff like that. But yeah, that's it. And I'm looking for more questions. Does it support S3, HDFS? So in terms of, I want to specifically answer S3 and say that at the moment, like I said, in terms of kind of a target and a source, it's just a data warehouse as target and source, but we definitely understand in the future, you might want to push your data from data frame to an S3 bucket or a file, whatever. Those are things which are on the roadmap. Whatever you can do within Python, you can do directly, by the way. This is not something out of Rivery. So if you want to just within Python, push it to S3 or HDFS, go ahead, do it. But we are also trying to make that easier and more transparent to users by adding that functionality in the future. And we're actually just about out of time.
Also want to jump in here real fast. Any files that you create locally in your Python scripts will be local to those EC2 buckets. So sometimes we might have a situation where you want to extract the files, create a sort of temporary CSV file. That one will be created in the local Python resource. And then you'd be able to refer to it by directly typing the name of the file. And you can then take that file, push it to an API, take that file, as Ophir mentioned, directly pass it to S3 through the Python script. And those files, however, will be wiped, I believe, after the River execution or sometime soon after that. We are building an ability to have like object storage or file storage in an S3 bucket, but for now, you can do it directly in the script.
Thanks a lot, JJ. So also just a quick reminder, at the end of today's session, there is going to be a really short survey. I would really, really appreciate it if you could stay 30 seconds at the end just to let us know how we're doing. We're always trying to make sure we're bringing you value. And also just as a follow-up, we will be sending the full recording to everybody who attended. We really appreciate you joining us today and also appreciate your feedback. So thanks again, everybody, and have a great rest of your day.
Thank you, guys.